Thank you, Hans, for the introduction. My talk is going to be about AI again. Well, this is the last talk about AI you have to listen to today. Or is it? My name is Dima. I'm from DXOS. Some background on what we're building. As a company, we're making two things, a platform and an app. Platform is created to build decentralized local-first applications. And at its core, there is a graph database we call Echo. It's local-first, works offline. If you go on a plane, your data is still there. Why we need that? Well, we're using it to build Composer, our take at a super app. It's built for real-time collaboration. It's made entirely out of plugins, so it's open and extensible. And we sort of call it an IDE for your data. Well, that's background. Let's get back to AI now. So this is my new keyboard. Who else is using Cursor? It's so much enticing than GitHub Copilot for me, at least. GitHub Copilot works on predicting the next line of code you write, but Cursor goes deeper. It sort of models your brain as a developer. It predicts your next edit. So it's like having a second brain while you're programming. Well, and it's been crazy the last couple of years. Like, you have so many new inventions since ChatGPT. Right? It's not just answering questions. It can search the web. It can control your computer. Well, you have agents writing code with Claude for you. Right? I'm soon going to be out of a job. Now, well, how did we get there? ChatGPT 3.5, I believe, was the first AI that sort of gained traction everyone is using. But it was a basic question answering machine. You sort of give you a prompt, maybe some instructions, and it's using all of the data it was trained on to answer your question the best it could. Well, but most of the answers are generic. It doesn't really know anything about you as a user. Well, and to make answers less generic, there is RAG. So now, as a user, you can upload your documents. You can upload your PDFs, anything. And usually it's done through a vector store. It's going to index your data, and then AI can pull information from there and give you more personalized answers. So now we're getting more personal answers, but AI cannot do anything. We have tools now. Tools give our LLM hands, sort of ability to interact with the outside world. ChatGPT can search the web to give you better results, but it can also do actions like, send an email or create a calendar invite. With this, we sort of have agentic workflows going on where you can give it some task and it will go off and do it, right, using tools to sort of perform actions. Now, still with this, even though it's performing actions, all of the results of your conversation, apart from effects, still stay in the same chat. Once you close the chat, well, it's all gone. You haven't saved any outputs. Now, what Claude introduced was the concepts of artifacts. If you, let's say, go to the Claude desktop and ask it to create a website for you, it's going to go write HTML, CSS, and you're going to see it in the sidebar here. So it created something that stays beyond the conversation. You can hit deploy, and it's going to be present on the web. You no longer need the chat window. Our take at the artifacts is that I think we can go further. Instead of it just being words, tokens, we think that those can be actual real documents, real structured objects that you can interact with, that they have schema, they have tools which define actions of things you can perform with them, and I'm going to show it in my demo later on. Now, so given that, where can we go from there? Well, everyone is talking about building agents, and this is our take at agents. We think we need three things: context, tools, and orchestration. And here's the state of things today. Context is mostly unstructured data. It's chat logs, PDFs, that sort of thing. Tools, which started initially from a bunch of ad hoc standards, all providers introducing tools in sort of their own shape. Well, now we have MCP, which sort of gives you a generic framework of implementing tool calling in your LLMs. Now, last thing, orchestration. This thing doesn't really exist right now, but what I mean by orchestration is that right now you still need to be in the loop as a user. You have to give AI prompts, you have to turn the crank so it does something. If you stop chatting, it's not going to produce anything. Where we think we are going with context, we are moving from unstructured data to structure databases. Here we think FX schema can be really helpful because it's a language which you can use to describe the shape of your data. And it's only describing the shape, but it has a powerful annotation system where you can add extra things like descriptions or data formats, which then we can feed into an LLM to give it some sense of what the data is used for. And actually, FX schema was the first technology we adopted as DXOS, like Johan said. Now, tools. Current agentic systems, they usually operate within 10, maybe 20 tools at most. But in general, you'd want to connect your UIs to registries, maybe of 1,000 different tools, and that would pick specific ones which you need to get the job done. We can't really fit 1,000 tools into the context window. It will just get confused. So what mechanisms can we build so it intelligently selects which tools it needs for the job and uses them? Another thing about tools is, in general, it's a difficult problem to connect to external services. There's so much chaos, errors could happen, outages. This is where Effect comes in really well because it sort of tames that chaos and gives you things like error handling, retries, traceability, that sort of stuff. I'll show it in my demo. Now, last thing, orchestration. We've built a DSL for defining autonomous workflows that execute in background that can use both effectful functions and LLMs, which I'm really excited to show you to you. Right. On context, this is Echo. This is the database that powers our apps, and we also use it as a context window for AI. It's an eventually consistent database, which allows us to make it fully local first. It works offline, so let's say you take your laptop, go on an airplane, you don't have any internet, your data is still with you. You can keep working on your documents, change anything you'd like, and then when you get connected back to the internet again, it's going to sync across your devices and your team's devices. We built a sync engine using CRDTs. We're using auto-merge here as a conflict-resistant. CRDT means conflict-resistant data types. Now, Echo is also federated. It's designed so that your data is split into spaces, which are small work groups. Think about it as your personal files, or maybe your team's documents, or even I have a space which I use to prep for this conference. Echo API, well, we've built Echo with FX schema in mind. We use FX schema as a DSL for defining the shape of the data, but we added our own annotations there to help it integrate with the library. So this is an example of defining a data type with Echo. It's standard FX schema, but on top of that, we added our own annotations. Here we give the type a unique type name, which we can use to register it in the registry and then look it up, as well as a similar version, which we can use for versioning and things like data migration. Now, Echo is also a graph, so different objects can form relations with each other, and this is why we support references. So one object can reference another. Echo was first designed to work in local-first apps, and we have an adapter package to use it inside React. Here is an example of basic CRUD operations. So there is a hook to query objects of a certain type, create a new object, mutate it, and delete it. And what's interesting here is, first of all, the objects you get, they look like plain JavaScript objects. We use the type returned by FX schema to type the objects, so it looks like a plain object, but in reality, it's persisted on disk, that's one, and the second is it's replicated to other peers, so it's synchronized. Whenever you make changes to the object, and to make changes, you just assign property, like if it was a plain JavaScript object. Whenever you make changes, they get replicated to other peers, and then the changes those peers make get replicated to you. If the object does change, you'll receive notifications using signals. We actually integrate with different signals library, and you can pick the one you use. So you can use it with Preact, that's what we do, but also Solid.js and other signal-capable libraries. And yeah, Echo is really useful inside React because we support optimistic mutations. So you can just store all of your application state in Echo, and your handlers change the objects, and then you render them directly. Now, well, that's enough talking. Let's get to the demo. So this is Composer, and Composer is made out of plugins. We have about 2,000 of them right now, and we're still building. In fact, I was presenting from Composer all this time. We have a plugin that allows you to build slide decks with MDX. So this is my slide deck. But apart from that, we have things like spreadsheets, other documents, and so on, so on. One thing that we are focusing on right now is integrating AI into Composer. So let me show you. I have a conversation with an AI bot right here, and let me say hello, just making sure it works. And there might be some latency. This is calling out to Claude, right? And you see we support chain of thought, so we can read its internal thoughts, and it's sort of planning more thoughtful responses to your conversations. But this agent right here has access to all of the different tools from plugins that Composer consists of. So let me ask you, what tools do you have access to? And let's wait for it to process. Chain of thought. Yeah, and it's going to print this table of tools. So all of those tools that you see on screen right now, those are contributed by different plugins of Composer. In fact, this is fully extensible. We have things like scripts, markdown documents, maps, so on and so on. One of the plugins we've built is a plugin to play chess, which is a fun one, good for demos. So coming back to the conference space right here, I'm going to say, show me the Italian game. So this is going to analyze my request, sort of look up the position for what Italian game is, and it's going to call a tool provided by the chess plugin. So what it does here is it creates a new artifact with a predefined position using fan. The chess tool then creates an entry in the database and returns this artifact ID. Now, using the ID, the assistant can call another tool to display the chess game to me as a user. And here's the game right here. Is it wrong? Yeah. Well, one tool we can build is connected to a chess database, so it doesn't need to hallucinate the position, but can actually pull it in from the registry. But that's for later. Anyways, the point I'm making is this is not a static chessboard. This is a live artifact, so I can interact with it. I can make a move right here, and then let's say I've made the move, so now you play the next move for white. Right. So here's its chain of thought. It's going to inspect the current state of the chessboard, and I'll call another tool to make a move. So it's called the knight. It moved the knight right here. Yeah. So chess is fun, and this entire demo I've used tools that were already provided by Composer plugins. But now let's do something else. Now let's go through the motions of creating another tool straight in Composer. One of the plugins we have right here is an integrated code editor right inside Composer. I have a template for a function right here. So this template, all functions have two things. One of it's metadata, and the second one is the implementation. Metadata tells the system when the function could be used, like this is the description right here. This is important for AI agents. And also it has the input schema. So this is the parameters that the function takes. We're using effect schema for this. Two reasons. One, it's type safe, so that we can type this entire implementation, because we know that the implementation is going to take the schema as arguments. And then, well, the second reason is that we can serialize the effect schema and store it inside echo. This way, when AI discovers that the function is there from echo, it can infer what parameters it should take. Now, I've just deployed this function, and before I go to the AI chat, let me show you how you can use it from the spreadsheet. I'll give it a short name like forex. And then in my spreadsheet right here, if I start a formula, yeah, my function is going to be there. So I can provide the parameters, and it's from and to, like in the schema. And if I multiply it by a value, yeah, here's the exchange rate. So this calls out to the function, and the function is being deployed at Cloudflare. We have an edge service, edge compute service that's using Worker for platforms to run those functions for you. And yeah, this is fully live and reactive. So if I change the currency, yeah, it updates. Now, going back to AI Assistant, you can see that the tool list right here was updated because now it discovered the new function I've deployed. All the interaction here is happening through echo. That's the shared context between AI and the user. So with this in mind, I can say, what's 1,000 yen in US dollars? And it correctly will discover the function and call the function to get the latest exchange rate and show me the result. Those are just little demos. Now let's try to do something more integrated. Another plugin we have in Composer is a calendar integration. I've already preloaded some calendar events relating to this conference trip. So now let me ask it to, based on my calendar events, create a table with my travel itinerary. So here's its chain of thought. So it's first going to call the calendar tool, get the calendar events right here. Then what it's going to do is create a new schema. There isn't an existing schema in the database to represent travel itineraries, so it decided to create a new one. This is what I mean by echo being a structured database. Not only the inputs to AI are structured and have schema, but the outputs as well. So it's going to create a new schema with date, title, location, and coordinate columns. And here's the table right here. And now it's trying to insert rows into the table here. So those were inferred from the calendar events. Each one has a date, location, and it's also inserting coordinates on the map. It already suggesting to us that we represent it on an actual live map. This is another plugin we have for Composer. There's about 2,000 of them, by the way. So I've clicked the suggestion. It's creating a map artifact. And well, unfortunately, something went wrong here. There should have been pins on the map from the table. Let me see. Oh, so unfortunately, the format that the LLM picked to represent those coordinates is wrong. Well, there is some variability here in the demos, as we said, with the LLMs. Not everything always works. So, yeah, let me go back to the slides now. This was the demo. Thank you. That was a lot of things relying on the LLM working correctly. This is our system diagram. So on the left is Composer. This is what I showed. It's made entirely out of plugins, text, tables, spreadsheets, so on. On the right are the cloud services. We built a bunch of them, but the two I want to point out is the function service. This is compute for running your code in the cloud. This is what's executing my Forex function that I've deployed. The second one is the AI service that's running the LLMs. In the middle is Echo, sort of, I call it the fabric that connects the two. It's connecting services to the apps, to the user's data. And the circles are spaces. It's a graph of graphs. Each one is maybe your personal notes, your team's documents, whatever. Now, that was context and tools, but the third thing I want to talk about is orchestration. This is Conductor, a visual programming environment. It's a block editor. So we have a library of blocks here. And I can drag them onto the canvas, and if I connect the two, this is the simplest circuit. Now, you probably already seen this pattern in other software, and we are extending it to work with compute pipelines. We can make more complex circuits. In fact, we have a whole library of components right here, and each one of those is represented as an effectal function. So similar to the Forex one I deployed earlier, but each one of them has an inputs, outputs defined by effect schema, and an effectful body that accesses the implementation. So we can build simple logic gates out of them. But here's something more fun. We added a GPT node to the canvas. And this one is more complex. It has 5 inputs and a bunch of outputs, but it's the same principle. It's defined by the schema and has an effectful implementation. Here, I've configured GPT with a text-to-image tool. And the prompt I want to give it is create an image of a cat. Here. This was fast. This is actually running locally in our test environment. I'm using Olama here to run the storybooks, and a very small model. I think it's only 3 billions. But the point I'm making here is that by composing little independent functions into bigger workflows, you can build pipelines like this. So the way it works is Conductor will analyze the entire graph, and it will topologically sort all of the nodes and then plug the inputs to the outputs of the nodes. And at the end, we get a single effectful function from the input to the output. In this case, the input, the entry point, is this chat box right here. I'm just manually typing in the message, and it executes the workflow. But we can create real things with it. Here's another space. We use this space as a CRM for our Discord server. It's a QA space. What do I mean by that? Well, this workflow right here operates on a cron trigger. It will execute about 10 seconds or so on our compute service on Edge. And it will call a function we created. And the function uses the DFX library from Tim to connect to the Discord API and query the latest messages from our Discord server. Like the previous functions, it has the schema defined. And actually, I want to point out that this schema right here is the same schema you see on the block here on the node in the canvas. Now, the function is going to execute about 10 seconds or so, query the new messages from the Discord server, and then place them in a durable queue. We have another workflow which will take items out of the queue with another type of trigger. This is a queue processing trigger. And then it will append questions that the users ask in our Discord server to this Kanban board right here. So now we built a simple CRM to act as a QA pipeline in our server. Yeah. And by the way, Kanban is yet another plugin of Composer. Oh. So those have been all the demos, but what is the point I want to make with this talk? It's not that we've built an app that can integrate with Discord. What we're creating are building blocks. Echo as the database, functions, orchestration for maybe thousands of different use cases. There are a lot of things you can imagine building with this. So if anything I said today sounds interesting, I invite you to try out Composer. We've just released Alpha 0.8. And you can find us at our Discord server, or we also have Rich and Josiah from our team at the conference right here. Come say hi. And thank you.